All right. Hey, guys. um, so today, this week, we have a couple more things we're going to learn. We're going to learn about graphing linear inequalities. So it's a little bit more than just testing to see if an inequality is true or not. What we are going to be doing is basically solving inequalities and keeping them in the form of y equal mx plus b. Okay? Well, um, so what we're going to start with is our notes. So a solution, remember what a solution was. It was some point xy of an inequality in two variables is an ordered pair, xy, that makes the inequality true. So when we plug x in, the x value in for x and the y value in for y, the entire statement is true. So the rules to our little warm up here, like we would be doing in class, says determine whether the ordered pair is a solution to the linear inequality. Justify your answer. Well, what does all this mean? This means for this inequality right here, we're going to plug in x and we're going to plug in y and we're going to evaluate it. We're going to simplify it down and find out if it's true. So negative 1 would be 7 times negative 1 plus 1 2 times 1, is that greater than or greater than negative 5? We're asking the question, is that true? So negative 7 plus 2 is greater than negative 5. Negative 5 is greater than negative 5. So is that a true statement? True or false? That's what we're asking. Is it true or is it false? It is false. What does that mean? That means negative 1, 1, the ordered pair, is not a solution. So that's how this game is played. Okay? So the answer, not only did I evaluate it, I justified my answer. So if I ask you to justify in homework, this is what I mean. Okay? So moving along, let's do the next one. I didn't put my line down on the last one. Okay? So this is x. It's always a good idea to just put an x and a y there so you don't put the wrong value in to the wrong place. 1 plus 2 times 4, is that greater than 5? 1 plus 8 greater than 5. I know you know the answer already, but I'm going to finish it out. 9 is greater than 5. That is true. So 4, 1 is a solution. Okay? It is a solution. Moving on. This is x, this is y. So x is negative 8 plus 4 times negative 2 less than or equal to negative 2. Negative 8 minus 8 less than or equal to negative 2. Negative 16 less than or equal to negative 2. True. Solution. It is a solution. So this is kind of like what we were doing in homework last week. Here's x, here's y. I'm going to plug them in. X is 2. Take away a negative 1 less than or equal to 3. 2 plus 1 less than or equal to 3. 3 less than or equal to 3. So is that true or is that false? It happens to be true because 3 equals 3. And this inequality right here says that it's true whenever this value is less than or equal to. This is an or. Okay? Cool. All right. So graphing linear inequalities. Graphing linear inequalities. Steps. Okay? So we're going to go over the steps for graphing linear inequalities. So, boy, I got a frog in my throat this morning. First things first. So 1 is first, right? we are going to graph the boundary line. Okay? Well, what does that mean, Mr. Sterling? I'll tell you what that means. That means solve the inequality in the form y is whatever our inequality is. It can be less than, it can be greater than, it can be less than or equal to, it can be greater than or equal to mx plus b. Put it in slope-intercept form with this being the inequality, okay? And one thing to remember, flip the inequality when we multiply or divide by -1. Both sides, right? Both sides. Don't forget that. So, second step. Second step. Trying to make that into a second. Second step, determine whether boundary line, determine whether the boundary line, I guess I should have the in there, the boundary line is a dashed, I'm going to capitalize that and write it in red, dashed line points not included or solid line points included. Line. Okay, so we are going to be determining whether the boundary line is a dashed line or a solid line. Okay, I will explain what that means. All right. Then the last step, the third step in graphing linear inequalities, is determine which side of the boundary line gets shaded. Okay? We will use test points to determine shading. All right. So when do I use a solid line and when do I use a dashed line? And how do you like this dash box or solid box? Well, when I have a less than or equal to, or I have a greater than or equal to symbol. When I have a less than symbol, or I have a greater than symbol. So this means points on the boundary line are included. Okay? And if you think about it, if it's on the boundary line and we have a less than or equal to, that means it's equal to if it's on the line. Then the point that we're testing is equal. Okay? So it's just the converse of this, the opposite of this. Points on boundary line are not included. Okay? Are not included. Cool. All right, so how do we play this game? Let's move this up so you can see the rest. All right. Something that's important to have is a ruler, a straight edge, you know, your student ID, something to make a straight line with. But before you need that, you need a brain. Haha. Okay, so make a line down the middle, and do the work, okay? So here's what I'm going to do first. I want this to look like y equal mx plus b, except it's not going to be an equals. It's going to be a less than or equal to or a greater than or equals to, okay? So what I'm going to do first is I'm going to minus 3x and minus 3x, and I'm going to rewrite this as y is less than negative 3x plus 6. Okay, cool. Now this looks like that, except that I have an inequality instead of an equals. Okay? So if I were in class, like last semester, if we were sitting in class right now, I would be saying to the class, what's my slope? And you would all say, m equal negative 3 over 1. And I'd say, what's my y-intercept? And you would all say, b equals 6. Okay? And how many points do I like you to plot? I want you to plot 3 points. Why? The reason I tell you to plot 3 points is so that when I lay my ruler down to make my line, if it doesn't line up with all 3 points, that tells me that I, the grapher, made a mistake in plotting my points. And I will go back and check my work. That's why we want 3 points, okay? So, first thing I'm going to do is count up. 1, 2, 3, 4, 5, 6. And there's my first point, 0, 6. Okay? So my y-intercept was 0, 6. All right? Cool. Now, this is down 3 and right 1, or it's up 3. We could also have written slope as 3 over negative 1. So it's either up 3 and left 1, or this one over here is down 3 and right 1. Remember, no over. It's left or right. Left means negative, right means positive. So a positive 3 over a negative 1 is negative 3. A negative 3 over a positive 1 is negative 3. So I am going to go 1, 2, 3 down, and 1 right. Okay? 1, 2, 3 down, and 1 right. And just to show you what I'm talking about, I'm going to go up 1, 2, 3, and left 1. So I plotted 4 points. Now, big question. Is this line, is this graph solid or is it dashed? And I know what you're saying at home. It's dashed. You're correct. So I'm going to take my ruler, I'm going to line it up, and I'm just going to make dashed line. Make it a dashed line all the way down, and all the way up. And I'm going to put arrowheads on my line, just like I did last year when I graphed in equalities. Now, the question becomes, do I shade to the left or do I shade to the right? Do I shade over here or do I shade over here? All right, how do we find out? We test, use a test point. Okay, don't pick a point on the line. Don't pick a point on the line. Do you hear me? Do not pick a point that is on the line. Okay? So, my favorite point to use, my favorite all-time point to use is this guy right here. If he is not on my line, I will always use 0, 0, and I will show you why. So, here's what we're going to do. We're going to use 0, 0. We're going to take our inequality. Our inequality says y is less than negative 3x plus 6. So we're going to plug it in. 0 is less than negative 3 times 0 plus 6. We get 0 less than 6. Is this true or false? It is true. Guess what that means? That means we shade on the left. That's what that means. So here's the deal. I picked my test point on the left. My test point was true. So that means I'm going to take and shade this whole side over here. Okay? So here's what this means. This means that this is the inequality. Y is less than or not less than or equal to, is less than 3x plus 6. I took my test point. Now I'll write that. Oh, it's right here. My test point of 0, 0, and I plugged it in. Okay, I plugged it in. When I plugged it in, it was true. If it were false, I would have shaded over here on this side. But it wasn't false, so I shaded here. All right, I think you're getting it. I'm going to pause the video. I'm sorry, you're going to pause the video. And you're going to work this one on your own. And then after you're done, and I want you to do exactly what I did. When you are done, I want you to start the video back up and check my work. Go. All right. So if I want you to think about this. If I leave this on this side, on the left side, I will eventually divide by a -3 and I will have to flip the inequality. Last week, I showed you 2 ways to do these inequalities. Okay? I could move it over. But if I move it over, at the end, I'm going to have to flip the whole thing like I did in last week's lesson. So I'm going to leave it here. And I'm going to subtract 2x from both sides. And then I'm going to get -3y is greater than or equal to -2x plus 12. Everybody knows why it's plus 12, right? Because this is a positive 12, so it's plus 12. Now, we are going to divide by -3, -3, and -3. Now I'm going to put a little asterisk here. And I'm hoping that what me drawing this asterisk has you saying, I know why, tell me why. Because I'm going to write down now what you need to do in case you forgot. Flip the inequality. Why? Because we divided both sides by -3. Now, this becomes y, no longer greater than or equal to, less than or equal to. Now, a negative over a negative is a positive. So I have a positive slope of 2/3 x minus positive over negative minus or -4. So my slope is 2/3. This is up and this is right. Okay, it could also be down and it would be left. Okay, so my y-intercept is going to be, well, b equal -4. So my y-intercept is 0, -4. So I'm going to go to 0, -4, 1, 2, 3. Let me do that again. 1, 2, 3, 4. And I'm going to count up. 1, 2, and right. 1, 2, 3. I will count down. 1, 2, 1, 2, 3. Okay, so I went up and I went down. If I lay my ruler down, notice they're perfect. Now, for demonstration purposes, what would happen if I went 1, 2, 3, 1, 2, and I marked the wrong point? Now, when I lay my ruler down, do you see how that point's not on the line? This is why Mr. Sterling wants you to use 3 points. Because when you go to put your straight edge down, ruler, whatever, and it doesn't line up, you're going to say to yourself, ooh, I messed up. And you're going to go back and you're going to check your work and you're going to go, oh, I see what I did. I counted the rise and anyway, I counted wrong. So I want to do rise over run. So down 2 and left 3. And now they line up. And then I want to ask myself, the second question was, determine the boundary line. Is it dashed or is it solid? And it's solid. So I'm going to lay my ruler down, line up my points, okay? And I'm just going to take my marker, in my case, my red pen, and I'm going to make my line. And now what's left to do? So, by the way, that means every point on this line makes this statement true. And we could test it and prove it. I mean, if you plug in 0 and -4, you get -4 is less than or equal to -4. So it does work. Now, what I want to test, though, is another point. And I'm going to test, again, you guessed it, 0, 0, because 0, 0 is so easy to work with. So my test point is going to be 0, 0. Okay? So 0 less than or equal to 2/3 times 0 minus 4. Okay? So 0 less than or equal to 2/3 of 0 is 0. Ah, negative 4. And 0 is less than or equal to negative 4 is false, because 0 is greater than negative 4. So what does that mean we're going to do? That means we're going to shade this side of our inequality. And you don't have to be perfect, okay? Just if you did that much right there, you're perfect. Some people like to do dashed lines like this around this side, I don't care. Just make sure you indicate which side is true, which side is false. And there endeth the lesson, okay? You have all of these wonderful notes to go back and look at for reference in order to finish your homework.